Alright, this video is the first for Unit 5, and starting off easy with just classifying quadrilaterals. Now, so obviously this is already filled out, but we're going to go through this. So, these get used more than once, and it's a matter of what do they go with. So, a parallelogram. It has two sets of parallel sides. It does not have four congruent sides. It does not have exactly one set of parallel sides because it has two sets of parallel sides. It does not have exactly one set of congruent sides because opposite sides are parallel, or opposite sides are congruent. It does not have four right angles, but it does have four sides. So A and F. Now, a trapezoid. Now, considering we're classifying for quadrilaterals, F is a given for all of these. Now, for a trapezoid, it does not have two sets of parallel sides. It does not have four congruent sides. Exactly one set of parallel sides. That's true. It has basically the top and the bottom are parallel. Exactly one set of congruent sides. Not true. Four right angles. Not true. And then four sides, of course. Isosceles trapezoid. Two sets of parallel sides? No. Four congruent sides? No. Exactly one set of parallel sides? Yes, because it's still a trapezoid. Exactly one set of congruent sides? Yes. The isosceles part means it's going to have one set of congruent sides. Four right angles? No. And four sides? Yes. Rhombus? Two sets of parallel sides? Yes. Four congruent sides? Yes. Exactly one pair of parallel sides? No. Exactly one set of congruent sides? No. Four right angles? No. And four sides? Yes. Sorry, I skipped rectangle. That's going to have two sets of parallel sides. Not four congruent sides. Not exactly one set of parallel sides. Not exactly one set of congruent sides, but it will have four right angles and four sides. Now the square, two sets of parallel sides, yes. Four congruent sides, yes. Not exactly one set of parallel sides. Not exactly one set of congruent sides, but it will have four right angles and four sides. Now, if we take a look at this next part, always, sometimes, or never. So, a square is always a rectangle. If we switch it around, a rectangle is not always a square, but a square is always a rectangle. A parallelogram is sometimes a rhombus. A rhombus is always a parallelogram, but a parallelogram is only sometimes a rhombus. A trapezoid is never a rectangle, because if we look up here, trapezoid has exactly one set of parallel sides, and a rectangle has two sets of parallel sides. So it's never a rectangle. And a rectangle is never a trapezoid. Now, a rhombus is sometimes a square, because rhombuses don't have four right angles. A square is always a rhombus, but a rhombus is only sometimes a square. And a rhombus is always a quadrilateral. Now, we look at this. Which of the following quadrilaterals always have diagonals that are congruent? Choose all. Well, rectangles and squares always have diagonals that are congruent. Okay. Excuse me. Which quadrilaterals always have opposite angles that are congruent? And that's all of them. Okay. In a parallelogram, opposite angles are congruent. In a rectangle, they're always congruent. In fact, in rectangles, all angles are congruent because they're all 90. In a rhombus, opposite angles are congruent, and in squares, they're congruent. And again, just like rectangles, they're all 90. And then which quadrilaterals, I don't know why I'm having so much trouble talking right now, but which quadrilaterals always have diagonals that bisect opposite angles? And again, choose all. That's rhombi, rhombuses, rhombi is actual plural, and squares. Okay, parallelograms don't, and rectangles don't, but rhombi and squares do. Okay, they bisect the opposite angles. Now, getting a little more specific, some properties of rectangles. Now, rectangles have the same properties of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So all of this is true of parallelograms. But for rectangles, all four angles are right angles, and the diagonals are congruent. So this is all true of parallelograms, but for rectangles, we add these two. For rhombi, again, all this for parallelograms, but then for more specifically to rhombi, all four sides are congruent, the diagonals are congruent, and the diagonals bisect each other. And then a square has all the properties of a parallelogram, a rectangle, and a rhombus. So everything that all the others have. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. For right angles, diagonals are congruent. For congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. Okay, so those are the properties of quadrilaterals. Okay, and so that's basically all we're going to deal with today. Now, as you can tell a little bit from below, we are going to end up at the point where we do proofs dealing with properties of the quadrilaterals. And you can see that they will be more complicated than what we're currently dealing with. But to start with, we're just going to deal with the properties. Okay? Have a good night, and I will see you tomorrow.